Welcome back to BSpice. In OT cybersecurity, in this session, we'll continue with defense in depth architecture capabilities, wherein we'll focus on layer 5, which talks about software security. So, hope you have watched my previous session on the same defense in depth architecture capabilities, wherein in layer 1 we talked about the security management, layer 2 we talked about the physical security, and layer 3 we focused on network security. And of course, layer 4, we focused on hardware part. Now, layer 5, the last session in defense in depth capabilities, software security is going to be dealt in detail. Let's talk about this layer 5 software security. Friends, software security protection mechanism provide organization with capabilities to ensure that applications and services supporting OT are used and maintained properly. So that's the main intent. Overall, software security capabilities can enhance endpoint security when organization incorporate these aspects. What are all these aspects? Application wide allow listing and patching, secure code development, configuration management, including application hardening. So this is the topic of this session. We are going to talk about these four aspects here. Let's get started. Yes, application allow listing. Application allow listing technologies provide an additional protection mechanism on host by restricting which application are allowed to execute, which application are allowed to execute. When properly configured, non-authorized application will not execute on the host environment. When considering application whitelisting within an OT environment, organization should coordinate with the vendors and review available guidance in line with the NIST SP 800-167, which is talks about, which focuses on the application whitelisting. Hope you're aware of this NIC, right? National Institute of Standard Technology, right? So this we have already talked. If you are interested, you can also refer to our video which talks about this in detail. Okay. So this is about the application whitelisting. So the point is the configuration and policy should be thoroughly tested before being deployed to ensure that the rules and settings properly support organizational security objectives. So to add on a few more on this, so we'll talk about the patching here. Patches have two main purposes, in fact, to address vulnerabilities and to enhance functionality. I hope you agree with this. So in context of defense in-depth software security, patching is associated with reducing vulnerabilities, right? So as a result, patch management is a defense in-depth capability that supports vulnerability management as part of organizational risk management strategy. So deploying patches to OT environment requires additional consideration for organization, including testing and validation to ensure that patches do not impact operational capabilities or safety. Very, very important. See, when in the name of patch, if we get involved into trouble, then that's not good, right? So we have to ensure that patches do not impact operational capabilities or safety. OT operational requirements can also impact the frequency of which patches are applied. For example, some OT environment must run nearly continuously for extended period of time or have small maintenance windows for applying approved updates. So that's about the patching. To continue patching, additionally patching you know, older OT components that run on unsupported OSS may not an option. So in these cases, organization may want to consider updating their OS or investing in additional control that can protect the environment from attempts to exploit known vulnerabilities. So I'm not sure whether you are getting it, friends. We have older OT components, right? So patching older OT component that run on unsupported operating system may not an option. So in these cases, what we have to do, we have to consider updating the OS operating system, or we have to invest in additional control that can protect the environment from attempts to exploit known vulnerabilities. Some tools such as Web Application Firewall, WEF, and IPS, Intrusion Protection System, could be configured to provide additional protection to detect or prevent attacks against unpatched vulnerabilities while the organization wait for an opportunity to apply the updates. I hope you got this point, right? Some tools such as, we can use this web application firewall and IPS that can be, configured to provide additional protection when we are waiting for an opportunity to apply the updates. That's the point here. Other tools such as bump in the wire security devices can also be installed in line with the devices that cannot be updated or using obsolete. I think there's a typo error using obsolete operating system. So what is this bump in the wire? Bump in the wire, BITW, is a network security approach where a device is inserted directly into the communication path to inspect, secure, and modify traffic without changing the endpoints or requiring major network reconfiguration. So a bump in the wire device acts like a transparent security checkpoint. Basically, this guy sits between the two communicating system and ensure that all data flowing between them is inspected or protected. This setup is especially useful for legacy systems that lack inbuilt, security features. You got it, friends? Yes. Wherever possible, patches should be tested on sandbox. What is a sandbox? It's a test environment to ensure that do not cause problem before being deployed into the production system. So that's about the patching. To continue more on patching, organizations should plan patches and updates during scheduled maintenance windows for the environment and have a recovery plan for the OT component or the system being patched. Organizations should also consider the different levels, tiers, and zones may have a different availability requirements and as such may have different abilities to support patching. Whenever possible, organizations should prioritize patching components within DMZ environment and when vulnerabilities exist that impact availability and integrity or would allow unauthorized remote access to OT environment. So the point is we should prioritize patching components within the DMZ environment. So that's about the patching. Now we go into the third topic, secure code development. Organizations that develop in-house system and components should incorporate policies and procedures that support and validate secure code development practice into the cybersecurity program. The software development lifecycle, SDLC, should include security during each phase of software development. This should include security reviews, coding techniques for each of the following process. So what are all the process? The first one is using or developing tools to audit or automate the secure code techniques and also the testing and reviewing code to comply with secure coding practices and testing the software for security errors in programming. So for organization that procure components or services from third parties, reviewing the same practices should be considered prior to executing the contract with the vendors. Organization can help industries move forward to a more secure products by requesting these practices in their service level agreements and procurement actions. So that's about the secure code development. Then we have the last but not the least, the configuration management. Applying configuration management practices that support secure configuration and application hardening is very, very important to meet organizational and regulatory security requirements. I hope you agree with this statement. These settings may include setting access controls to restrict access or enabling encryption to protect data at rest or in transit. So you may be wondering, this gentleman is talking about encryption. See, what is this encryption basically? So encryption is nothing but, the process of converting the readable data into a, unreadable format to protect it from unauthorized access. Basically, the readable data means it's in the plain text. So we need to convert that into unreadable format, that is ciphertext, so that to protect it from unauthorized access. So that is the point. And here encryption protocol means it's a standardized protocol that uses cryptographic algorithm to secure data during transmission or storage, thereby ensuring confidentiality, integrity, and authenticity. That's the point here. Okay, so application hardening procedures may include, disabling or blocking specific network communication port, application feature, or unnecessary services that run on the system. Encrypting the data that flows over the network, whether it's in transit or data stored in memory or in the local storage at rest, can also be used in defending OT. So encryption prevents an attacker from viewing or modifying the clear text data streams because we are, changing into a ciphertext and readable text. So because encryption and subsequent decryption process use algorithm to create ciphers, encryption adds latency. Of course, that is not mean that is always there. So encryption adds latency, meaning delay, and may not be suitable for all OT devices. Yes, of course, we need to take note of this. So knowing the advantages and disadvantages of encryption can help organization make an informed decision on where to include encryption in the defense in-depth strategy. Organization should also consider using encryption to support secure connections or conduits for OT environment when connection must pass over a non-OT network segment such as corporate network or the internet. So very, very, very important, friends. Virtual private network VPN connection should be use encryption protocols such as transport layer TLS or internet protocol security IPsec to secure the data. So you may be wondering what is this TLS, right? Yes. So TLS is nothing but, again, protection data basically. Yeah, it's a transport layer security. What do you call? Just a moment, friends. Yeah, it's a transport layer security. TLS is a cryptographic protocol that ensures secure communication over network by providing encryption, authentication, and data integrity. It's mostly used to secure web traffic. You know this HTTPS, right? When we type the address, site address, right? Yes, and email and other internet based services. So basically this guy, the TLS, protects data as it travels between clients and servers by encrypting the data to prevent eavesdropping and authenticating the parties involved using the certificate and ensuring the integrity of the so that the data isn't altered in transit. So it's operate between the transport and application layer of the TCP IP stack, making it transparent to users and applications. So that's about the TLS. Then IPsec, Internet Protocol Security. So what is this Internet Protocol Security? It is again a suite of protocols used to secure IP communication by authenticating and encrypting each IP packet in a data stream. It's widely used in virtual private network to ensure secure private and connections over public network. So yeah, basically this guy IPsec enhances the basic internet protocol which lacks built-in security by adding the encryption so that to protect the data from being read by unauthorized parties and also provides authentication to verify the identity of the sender and receiver and also ensures the integrity by ensuring the data hasn't been altered in transit and also anti-replay protection, meaning prevents attackers from reusing intercepted packets. So that's about the TLS and Internet Protocol security to secure the data. Encryption can also be used on hard local storage to protect information at rest. Full disk encryption is also recommended for portable laptops and devices. Organization may also want to consider encrypting folders that contain sensitive files. So to continue with configuration management, organization must also consider the encryption can negatively impact other defense tools such as network monitoring. For example, friends, an IDS intrusion detection system might not be able to determine whether an encrypted packet is malicious, resulting in either false positive or false negative alerts. So that's a challenge actually. Yeah. See what we have to do, in that case, we have some, this one also. Like, for example, we have to use intrusion protection system with SSL and TLS inspection. So, this SSL and TLS inspection is nothing but, SSL means secure socket layer. Okay. TLS means transport layer security. Okay. So, when I talk about this, since IDS might not be able to determine whether an encrypted packet is malicious, resulting in either positive or false negative aspects, right? So we have to do some intrusion protection system with SSL and TLS inspection, meaning deploy inline IPS that can decrypt and inspect encrypted traffic. So those kind of things we have to do for this actually. That is the point. So organization must consider that encryption can negatively impact other defense tools such as network monitoring. For that, we have to use intrusion protection system with SSL and TLS inspection. Also, you have to implement SSL and TLS termination at a secure gateway. At a secure gateway. So these are some of the aspects we should focus. We should not go into beyond it. Beyond we are the topic for this session is beyond the this. So that's why I'm stopping with that. Anyway, let's go into this other points. Organization should also create procedures to manage changes, to control logic, to protect against risks that improperly tested for malicious changes to logic could disturb the system. So we should also create procedures to manage changes to the control logic. So that's all I have for this defense in depth architecture capabilities, friends. I have done with that. Thanks again for those who supported. Okay. So thanks again. I'll see you in the next video wherein I'll talk about very, very important aspect of cybersecurity architectural model. Very, very important topic. So don't miss it. So what I'm going to, cover is, like distributed control system based OT system, and also how to, what do you call the defense in depth security architecture with respect to the DCS, and DCS and PLC based OT with IIoT, and SCADA based OT environments. All these actually, all these we are going to cover, friends. Thanks and stay tuned. Take care. Bye bye.